Hey guys, welcome back to another video in Calc 3, and today we're going to talk about vector magnitudes, and this is probably one of the more important topics in Calc 3 just because a lot of different ideas are built upon knowing about vector magnitudes. So I'm going to spend some time talking about them. And though obviously the point of my video is explaining these concepts in the simplest way possible, so I'm not really going to get into any proofs or anything of that nature. My goal is to just drive the point home. So with that in mind, let's dive in, and feel free to pause this video at any time if you need to read my notes, or drop me a comment if you're not sure about something. Alright, so we know from our first lesson that a vector has both a magnitude and a direction. And we never really spent time talking about the magnitude just because I felt like a lot of other lessons were needed to explain what a direction is. And then today, I'm going to expand the topic on a vector magnitude. So the way we're going to calculate a vector magnitude is through that formula that I wrote in red pen over here. And obviously another point to consider is whenever you're representing a magnitude of a vector, you want to enclose that in like kind of double absolute value signs. And some textbooks go with just one absolute value sign, though I like the second one better. You're being more specific in my opinion. And then, imagine you're given the vector P equals, you have point A, point B, and then the magnitude of this vector can be obtained using that formula over there. And I'm gonna explain what this formula really means in just a second. And going down, remember that we talked about the direction. So if you look at that vector P, it's got a direction, we could say that the direction is probably northeast, and then the length of that vector P, that's going to be your magnitude. So in a nutshell, a vector magnitude is the length of a vector. A magnitude is a length of a vector, okay? And so I've got vector P here, and then to my right, you could see a longer vector P. And in a way, we could see that, this vector P right here, that's double the size of the first vector P. So we could say that, this is probably 2 vector P in order to differentiate the size. So all a vector magnitude really does is it basically talks about the length of a vector, okay? The length of a vector is going to be your magnitude, okay? So just something to keep in mind, and I'm going to keep repeating it down the line. And then if you're in physics, you're obviously going to be talking about vector magnitudes. And so vector magnitudes also describe, how much force is being pushed on a vector. And obviously with like larger vectors, you're going to have a larger magnitude. So this also goes with speed as well, but I'm not really going to go into physics here. So let's talk about our first example to make some sense out of what we just talked about. All right, so we're given vector k. It's going to have the components 5 and 1, and we want to find the magnitude of this vector. Well, we know that the magnitude of vector k can be obtained using that formula above. So that's going to be 5 squared plus, plus 1 squared. So that's going to be what? That's going to be 5 squared is going to be 25, plus 1 squared is going to be 1. So the magnitude of vector k is going to be rad 26. And obviously you could calculate this, or you could simplify the square root further down, but I'm just going to leave it as that, all right? So nothing too complicated here. If you're given a problem, if you're given a vector, such as the one that we have here, and then you're asked to find the magnitude of that vector, all you're doing is you're using that formula above, okay? So you're basically taking your first component, squaring it, second component, squaring it, and then taking the square root of the whole thing. And, once you do that, there is your magnitude. There is your length of that vector, okay? So in order to make some more sense out of this, we're going to talk about our second example. And this is probably a pretty common example that you're going to see in your exams or in your homework. So we're given a set of points, P and Q. So point P has the coordinates of 1 and 1. This is not a vector, just to make that clear, because it's not inside of a bracket. We typically represent vectors with brackets. All right, so we have points P with the coordinates 1 and 1, and then we have the point Q with the coordinates of 5 and 3. So in other words, X is going to be 1, Y is going to be 1, and then for that one, 5 is going to be X, and then 3 is going to be Y. All right. And in order for us to find the magnitude of this given problem, we first need to make a vector out of this. Okay. And the way, I have a lesson on this, the way we're going to go from a point to a vector, let's say I want to find vector PQ. All right, so I want to find vector PQ. All I'm going to do is I'm going from right to left. So I'm going to take my point Q, and then I'm going to subtract that from my point P. All right. Whenever you're trying to find a vector magnitude, not a magnitude, just a vector from a point, all you're doing is you're taking your second letter in your vector that you want to find its components, and then you go to the right. So point Q is going to have 5 and 3, and then point P is going to have 1 and 1. All right, so doing that subtraction, let's see, 5 minus 1 is going to be 4, and then 3 minus 1 is going to be 2. All right, so vector PQ can be represented with 4, 2, the components of 4 and 2. And then now we have this in the form that we know and like, so we could go and find the magnitude of that vector. And then, we could just say, magnitude of vector PQ is going to be equal to square root of 4 squared plus 2 squared. There we go. And then so that's going to be 16 plus 4. And then we're going to have the square root of 20. Okay. And then square root of 20 is about 4.5. Okay, so the magnitude of vector PQ is going to be 4.5. That's basically the length of that vector. Another way you could think about this is the formula that we had above. This is basically derived from the distance formula. And if I go down, I can show how this works. All right, so on the second example, we remembered that the distance formula was square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and that pretty much gives you your distance. And then our points are going to be, let me actually draw the points as well. So here's a coordinate plane. And then we have the points 1 and 1. So that's my y-axis, that's my x-axis. So 1 is going to be over here, 1 is going to be over here on y. So 1 and 1 is going to be there, and that's my point P. And then my point Q is going to have the coordinates of 5. So let's say 5 is going to be somewhere over here. And then we're going 3 units to the above, to the top with point Q. So let's say 1, 2, 3. So there is my point Q. And then that's essentially my vector. And again, we discussed that the vector magnitude is basically the length of that vector. And in order for us to find the length of this vector, we're basically going to use the distance formula. And then in order to do that, we're going to use that formula right there. So we can say that's going to be square root of what's my x2. So that's going to be 5 minus x1 is going to be 1 squared plus, and then my y2 is going to be 3 minus my y1, y1 is going to be 1. Oops. I hate when it does that. Let me see if I can get rid of that. There we go. 3 minus 1 squared. Okay. And again, so x1, if you look at the top, x1, y1, x2, y2. Okay, so hopefully that's making some sense. And then basically doing this, 5 minus 1 is going to be 4 plus 4 squared, my bad, plus 3 minus 1 is going to be 2, and then squared. So that's going to be 2 squared. Again, that's going to give us rad 16 plus 4, and that's going to be rad 20. And square root of 20 is going to be 4.5. Okay. So basically, we got to the same answer. And that goes to show that the vector magnitude is basically the length of a vector. Okay. In the example above, we're provided with an already existing vector. We have the components. So all we're doing is we're taking the first component, squaring it, we're taking the second component, squaring it, and then we're taking the square root of the whole thing. Okay. And over here on the second example, we're just given 2 points. Okay. And, basically we graphed our points, and then, over here we graphed our points, and then we mentioned that the magnitude is the length of a vector. So we could basically either make a vector out of that, which we did. That was the first method of solving it. Or we could just use the distance formula, and we're going to get the same answer. Okay. So hopefully that's making some sense, out of vector magnitudes. And that just about wraps up the topic here. If you have any questions, just drop me a comment, and then please leave a like for the YouTube algorithms so other people can see this video. And then I think that's about it. I'll see you guys in the next video. Peace.